Valence electrons are very, very important. Valence electrons are the electrons that actually engage in chemical reactivity. And we're going to use the periodic table to determine the number of valence electrons for a given main group atom. So it's really important that you can figure that out. So let's look at what we already know about number of electrons in the periodic table. For example, if we look at carbon, we can see from the periodic table that it has an atomic number of 6. So that means an atom of carbon has 6 protons as well as 6 electrons. But not all of those electrons are chemically reactive, and chemists really care only about the electrons that are chemically reactive, at least in this class. So how do we use the periodic table to determine the number of valence electrons? Well, the number of valence electrons is always the same for a given family or column. And in the periodic table in your textbook, the columns are numbered by regular numbers, 1 through 18, as well as numbers with a letter on it. We're only going to look at main group elements, which are the elements that have the A in the column number. So the number of valence electrons for a given atom is the same as the number next to the A. So looking at the periodic table, every member of the 1A family has 1 valence electron. Now hydrogen only has 1 electron in it, but all the rest of the members of that family have more than 1. For example, cesium has 55 electrons. Only one of them is the valence electron, and only one of them is chemically reactive. In family 2A, every single atom has 2 valence electrons. Family 3A, 3 valence electrons. 4A, 4 valence electrons, etc. The only exception to this is in the noble gas family, family 8A, helium. Helium only has 2 electrons, so even though it's in family 8A, it does not have 8 valence electrons because it only has 2 total electrons. So we're going to practice identifying the number of valence electrons for these 3 atoms, and then we're going to look at a model that's used to illustrate the valence electrons, known as a dot symbol or a dot structure, electron dot symbol or electron dot structure. So pause the video and see if you can determine the number of valence electrons for these 3 main group elements, neon, oxygen, and silicon. So by looking at the periodic table, we see that neon is in family 8A, 8 valence electrons. Oxygen in family 6A, 6 valence electrons. And silicon in family 4A has 4 valence electrons. Now let's take a look at the dot structure. What the dot structure is we use dots to represent the valence electrons for a given atom. And there can be a maximum of 8 valence electrons for the main group elements. And when we place the valence electrons as dots around the symbol of an element, that is our representation of the valence electrons in an atom. And we place those dots in a very specific order, always in the 12 o'clock, the 3 o'clock, the 6 o'clock, and the 9 o'clock position around the symbol. It doesn't matter where you start, whether it's the 12 or the 3 or the 6 or the 9, but the first 4 electrons must be distributed basically 90 degrees apart from one another around the symbol of the element. And then you begin pairing. So you can have a maximum of 2 electrons on each position of the 12, 3, 6, and 9 o'clock. So right here is table 2.5 from the textbook, and it shows you the dot symbols or dot structures for some typical main group elements. It also has the group number with the letter A next to it to show you that each member of that family has the same number of valence electrons that is same as that number. So for example, in family 3A, there are 3 valence electrons. So now that we know how many valence electrons these 3 elements have, neon, oxygen, and silicon, and you've seen what a dot structure looks like, pause the video and draw a electron dot symbol for each of these 3 atoms. And here's the answer. Neon has 8 valence electrons, oxygen has 6, and silicon has 4.